Assalamu alaikum. Starting with the name of Allah Almighty. So today in this video we'll be learning about the sieve analysis test calculations, and then we will try to learn about the drawing of particle size distribution curve. So this is very important and technical. So let's start with an example. Usually we use these sieve sets. Sieve sets can vary. There can be sieves which are greater than sieve number 4 as well, but the procedure will remain same. This video will illustrate the procedure, how we basically calculate the percentage sand, percentage gravel, and percentage fines from sieve analysis test, and then how we basically can draw the particle size distribution curve. So let's start with an example. This is an example sieve number 4. Diameter is 4.75 mm, then 10, and so on. These are the readings from the test. The soil mass retained in grams on sieve number 4 is 25.87 gram, then so on for all the sieves. Now, firstly, I will have to determine accumulative retained mass. So how I can determine accumulative retained mass? For the first sieve, it will be same. I will apply the formula equal and will select this one, because for this sieve it will be same. Now for the next sieve, I will apply the formula. It will be this plus the previous one, this one. So this is how I will obtain the accumulative retained mass. Now I will drag this, and this will be applied to all columns. Now you can see the total mass retained on the pan is 497.2 gram soil. Now I have to determine the percentage accumulative mass retained. So how we basically determine? I will apply the formula of finding out the percentage mass retained. I will select this one and will divide it by total mass retained. So look, this is the total amount of soil mass used and total soil mass. So I will be dividing it by this one, and then bracket close, multiply by 100. Yes, so this is the percentage mass retained on sieve number 4. Now I want to drag this, but for this purpose I have to fix this column, because this amount will remain same. So I will have to apply this sign of dollar. Why I am applying this dollar sign? Because when you want to fix this amount is fixed, accumulative mass. So that is why I have applied the sign of dollar here. Now what's the benefit of it? When I will drag it from this to all the columns, then this will remain okay. So this will be okay. Sorry. Now I will drag this one, and the formula will be applied to all. You can see. Now what I will do, I will have to find out percentage passing. The percentage passing is basically 100 minus percentage mass retained. So I will select this one. Okay, now the formula will be applied. I will drag this one and till here. Okay, now I have found out the percentage passing. Now I will have to find out the percentage gravel, percentage sand, and percentage fines. Now look, percentage fines is basically the mass of soil that is passing sieve number 200. So look, what is the percentage passing, which is from 200 sieve is 0.98%. So this is 0.98%. Now for the gravels, the mass of soil that is retained on sieve number 4. So how much percentage of soil mass is retained on sieve number 4? So it is 5.2%. So we can say 5.2% is retained on sieve number 4. Now how much percentage of sand in our soil sample? So it is basically equals to 100 minus 100 minus, if I apply the bracket, this plus this one factor. So this is how we can find out the percentage gravel, percentage sand, and percentage fines. Now the next step is to find out the coefficient of uniformity and coefficient of curvature. So to find out these, we need to find out the diameter of 60% passing material, diameter for 30% passing material, and so on. So for that purpose, we need to draw the particle size distribution curve. So particle size distribution curve can be drawn like, we'll go to the insert, we'll apply this chart. Now what is to be done here, select data. Now we'll add particle size distribution curve. For x-axis there is diameter of the particles, so I will select this column. Yes. Along the y-axis there is percentage of passing, so I will select this one. Okay. Now look, the graph is plotted, but there are some changes in this particular curve. Now what we will do is we'll select this axis and we'll convert it into log scale. So I will just selecting this one, axis option, and now I will select logarithmic scale. Now the next thing is values are in reverse order. You can see this is the graph. How we can change the graph basically. So the next thing is we will convert these values in the reverse order. So we will select this one. So yes, now the graph, you can see the graph is plotted, but the further changes will have to be made in this graph. I will select this column and we'll go to label, and here I will select high, and you can see the values of y-axis are shifted to this side. The next step is to do what? We will select this one, right click and add minor grid lines. So I will select, and you can see here there are some minor grid lines. I will just double click over here to modify. I will increase the width of these minor grid lines just to make it visible. So you can see here the lines are now visible by increasing the width. You can change the color as well. Color, like if I select this one, you can see the lines are now visible. Now it's a semi-logarithmic graph. So now the next step is to find out the 60 diameter of particles against 60% passing. So for that purpose, you can see where the 60% passing lies in between. So 60% passing lies in between these two points 83 and 56. So corresponding to these, we will check the diameter of particles. It means diameter of particle against 60% passing lies in between these 2 points. So we can perform the interpolation to interpret the D60 value. But in Excel, we can apply a simple formula. Apply equals trend. I will select this trend. Now double click. Now I will have to select the values. For this known YS values, so I will select these 2 diameters because value lies in between these 2. I will select, now place comma. Now we'll select the corresponding passings like this. Yes, place comma, and next you can see here it requires constant. So I will write 60 and click enter. So this is a diameter of particle against 60% passing in this example. Now the same formula will be applied. You can see here trend. So for 30% passing, you can see 30% passing lies it between these 2 points, 56 and 22. So against 56 and 22, I will be selecting these 2 points. Now place comma. Now we'll select these 2 points, comma, and it is 30 and enter. So this is how we can obtain D30. Similarly, we will select D10, apply the formula trend, double click, known YS. No, 10% lies in between 9 and 22. So I will select these 2 values, place comma, select these 2 values, place 10, comment and enter. So this is how we have obtained D60 and D10. Now you can find out CU and CC. The formula of CU is D60 divided by D10. So I will apply the formula D60, this one divided by D10. So this is how we have obtained CU values. Now we will have to find out the CC, that is D30 square divided by D10 into D60. Now I will select D30. This is the D30. Because it is square, we can do like this as well. Close, divided by D30, D10 and D60. D60 multiplied by D10. Bracket close, and we have obtained CC, coefficient of curvature. Now the next, the main thing is to draw the lines of D30 and D60. And how we can draw these lines? Simply look, for D60 we'll draw a line like this and this. Now we have to draw the coordinates. Simply what I will do is, for D60, you can see firstly I will have to indicate the coordinates of this point. So what are the coordinates of this point? Along x-axis it is 10, and along the y-axis it will be 60. It will be 60. Now I will have to draw a line till this point. Now this point is basically 60 in the y direction, 60 in the y direction coordinate, and along the x-axis the value is equals to this point, D60. I will select this one. So this shows one line. Now for the second line, I have to draw a line from this point to this point, or you can say from this point to this point. So what is this point basically? This point is this along the x-axis, and in the y-axis it is 0. You can see if I have to plot a line from here to here, so at this point the coordinates are this, and in the y direction this is 0. Now I have to move from this point to this point. I will again select this value, and in the y direction I have to move 60. Okay, now you will see how I can plot the line. Select data, add, I will select this one, these lines. Okay, along the y-axis I will select this one, and you can see the line is plotted. Now you will clearly understand the purpose of doing all this. Again, add. Now select along the x-axis. I will select this point. I will select this point, this column, sorry, and you can see the lines have been drawn. Now you can see this is D60. The diameter of particle against D60 is this 60% passing. So I will repeat that how I have drawn the line. Look, if I have to draw a line from here, what is this point? This point is the coordinate of these points are 1060. I have drawn this. Now if I have to move the line from this point to this one, we can do like this. So this is how we can draw these lines. Now for the line D30, the coordinates will be same. It is 10 and it is 30 in the y direction, but the next point is, I will select this well, and this is 30. Okay, I hope you have understood the whole point. Now for the next point, I will be this value against this. I will be selecting this value. Now for this point, I have to write 0 and 30. Look, now I will again draw the lines, select data, add along the x-axis this one and this one. Now you can see that another line is drawn. Now for the next line, I will be selecting along the x-axis this one. Along the y-axis, I can select this one, and you can see another line is drawn over here. Sorry, this one. So this is how we can draw the lines D30 and D60. Now again, for the next step, we will draw the line of D10. For that purpose, again the next point start from 10 and apply equals to and this value. Okay, now for this point it is 10 because we want the line against 10% passing. Now for this point, I will be selecting this one, this one. Now it is 0 and 10. Okay, now we'll go over here, select data, add along the x-axis. I will select this value. Along y-axis, I will sorry. Yes, this one. Okay, another line is drawn. Add this value. Add, and now another line is drawn. Okay, you can see the graph now. Here the graph is pretty much clear now. So you can see how I have drawn the lines. You can understand the concept now. I have just simply selected the coordinates like this. Now we will modify this graph simply. Firstly, I will try to change the color of these lines. Double click and you can select this one, this point. I will select the color black. Now you can see the color is black now, and I want to draw an arrow. So I will select an arrow type, this one. You can see the arrow is drawn over here. You can increase the thickness even. Now I will select this line like this. Okay, Now we'll select the black color is already there. We'll increase the thickness, and now I want this to begin arrow type, so you can see the line is modified. Now I will select this line again. I will select the color black, and arrow type I can select this one. Okay, so you can do what so yes, black color. Similarly, this line can be modified. Color is black, and now begin arrow type. You can see no, and arrow type. You can select this one. Okay, so this is how we can modify these lines. The next step is simply I will showing the axis. So axis titles. This is particle size, particle dia in mm. So I can increase the size. Okay, now along the y-axis, along the x-axis, you can see you can write the percent passing. So I can increase the size as well. So you can see the graph is now pretty much clear. So I hope this is how we can make the calculations, and this is how we can draw the graph. You can further make changes in the graph. I hope you have completely understood the whole procedure, how we can calculate percentage, gravel, sand, and fines, and how we basically can draw the particle size distribution curve. So if you like the video, don't forget to subscribe. You can also join our Facebook group with the same page, and you can find the Excel sheet in the description as well.